Okay, next we are going to solve a word problem. In our written section, we solve a word problem using addition of complex numbers in real life. But in this case, we're going to be solving the word problem using, like by plotting complex numbers. And it's a real life situation. So the word problem is right here. John and Jimmy are playing battleships. John asks Jimmy for a hint on the coordinates of his battleships. Jimmy, sorry, I spelled it wrong. Jimmy gives him a slip of paper with the complex numbers 9 plus 4i, 2 plus 7i, 3 minus 2i, and 10 plus 10i. Help John find out which coordinates he has to call in order to hit Jimmy's battleships. Find the ordered pairs and explain what they represent. So with that being said, what we're going to first do is we're going to try to find the complex number, or we have the complex numbers. We're going to plot them so we know where he has to call in order to hit Jimmy's battleships. So the first one is 9 plus 4i. 9 plus 4i, does in the standard form a plus bi, where a is the real number. So remember that the x is the real axis and the y is the imaginary axis. Same with the intercepts. So the real intercept, which is a, which is 9, that would equal x. So pretend that 9 is x. You go over to the right because it's positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You go up 4 because 4 is positive. 1, 2, 3, 4. That is the first spot where one of the battleships are. With our second one, it is 2 plus 7i. With 2 plus 7i, remember that the 2 is the real, so we're going to go 1, 2 to the right because that is positive, and up 7 because that is also positive. So 1, 2, 3, 4, 5, 6, 7. That is the second point. So this is 1, 2. With our third point, it is 3 minus 2i. With our third point, remember that the 3 is the real, 3 is positive, so you're going to go to the right, 1, 2, 3. But in this case, the 2, it's a negative 2, so you're going to go down because negative means that you go down. You don't go up on the y-axis or the imaginary axis. So 1, 2, 3, down 1, 2, that is the third place. And last but not least, 10 plus 10i. So 10 plus 10i, both of these are positive, so you're going to go to the right 10 and up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's right there. That is our fourth point. So because it is a word problem, it does ask, it says help John find out which coordinates he has to call in order to hit Jimmy's battleship. He found out which coordinates he has to call in order to hit Jimmy's battleship. So you would show this as your answer, but you also had to find the ordered pairs. So with one ordered pair, it was 9 plus 4i, so that would make it 9, 4. Because to x is first, so 9, 4. Second is 2, 7. Because 2, 7. Third is 3, negative 2. Because it's to the right, which is positive. 3 down, which is negative 2. And last but not least, 10, 10. Because it is over to the right and up, so it's positive and positive. So you found the ordered pairs. And you have to write a sentence on what the final answer would be. So your sentence would be something like, so you're going to say what the ordered pairs were, and then you're going to say, so let's see, the ordered pairs were 9 and 4, 2 and 7, 3 and negative 2, and 10 and 10. So you're going to, remember you have to put the final answer in your own words, and so you're going to say that John John will have to hit points. So those points, you would list them here. Where Jimmy's ships are. So that's what they mean. That's what they are, is where Jimmy's ships are. In order to sink them, because you hit them to sink them in the game. And if you were to need to explain how you found this, you would just say that with the standard form of the standard complex form, a plus bi, and you would talk about how each of the equations, like 9 plus 4i, how the 9 is the a is the real number on the axis, the a axis, or the real x-axis is the real axis, which is the horizontal line, and so that is why 9 is the intercept. And same with 4 and the b and the imaginary. So thank you.